When we go to number 20, another one of these big word problems. We've got Shayna and Dan, and they're improving their yard by planting daylilies and ivy. Okay, they bought their supplies from the same store. Shayna spent $54 and got 4 daylilies, 6 pots of ivy. Dan spent a different amount, $51, got 6 daylilies and 3 pots of ivy. We want to know the cost of a daylily and the cost of ivy. Okay, so it's pretty easy to say, okay, I can see one equation has to do with Shayna, and I can see that one of them has to do with Dan's things. But I've got to identify and name those variables. I'm going to just use D for a daylily, and I'm going to use I for a pot of ivy. And it's how much those cost. Really, in a perfect world, you'd put cost of A or a pot of ivy. Okay? So, now I'm ready to rock and roll and make some equations. All Shayna's stuff put together was 4 daylilies plus 6 pots of ivy equals $54. All of Dan's things, he had 6 daylilies and 3 pots of ivy, totaling up to $51. Okay? Similar totals, different ways to get there. Again, everything's all lined up for me, so I'm thinking elimination. But I look at this 4 and 6, and I'm like, well, I guess I could turn them both into 12. But what sticks out to me is I know I can turn a 3 into a 6. More specifically, I want to turn it into a negative 6. So if I multiply this entire bottom equation by negative 2, I'm going to get what I need. Multiplication here is negative 12D minus 6I equals negative 101 or 102. Careful there, I just made a little mistake. I said 101, I would have gotten the problem wrong. I was moving a little fast. Use your calculator for this, okay? Whenever I go to add these two equations together, this is my elimination method. Those are going to cancel. I'm going to get a negative 8D equals, again, calculator problem right there. Calculator problem. I believe it's going to be a negative 48, but I'm not sure. So let's go in here and check. 54. This is plus a negative, which is just minus 102. Negative 48 indeed. Divide by negative 8, divide by negative 8, and I get that D equals 6. Half my answer right there. I've got to take this and plug it in to one of my original equations. I'll do that over here on the right. 4 times D, well, I know what D is. D is 6. Plus 6I equals 54. 24 plus 6I equals 54. Subtract 24, subtract 24. 6I equals 30. Therefore, I equals 5. In sentences, you would tell me that a daylily costs $6 and a pot of ivy costs $5. Rounding out our final couple of problems. Which of the following is not, it's in capitals, it's in big letters, not a solution to this system? What we're looking for is anything not in this double shaded area. The double shaded area is all our solutions, okay? So, when I look through this, I'm looking at all 4 of these points and figuring out which one's not in that double shaded region. If you're not sure on this, just graph them all and it'll start to become more clear. Negative 4, 0, right there. Negative 2, 5, right there. Negative 6, negative 2 is down here. Sorry, I did these in a bit of an odd order. I just went up, down, up, down. Very final one, 0, 4. It's right there. So a lot of people look and they say, oh, well, they're all solutions. Like, Mr. Sorrell, y'all got the problem wrong. But D is a tricky non-solution. Because it's on this dotted line, it actually would not be a solution to this positive equation, this positive sloping equation. Inequality, actually, would not be a solution. Also, just by, not method of deduction, but just by deduction, you can see that these 3 points, A, B, and C, are all very heavily in the double shaded region. The only one you even have to think about is D. If there's only one that you have to think about, it's probably going to be that answer on here. Okay? Anything in this zone would have been a non-solution. Anything up here, also a non-solution, or anything over here, a non-solution. But those would be probably a little bit too obvious. It might be something tricky. Just all these other three choices, A, B, and C, were all very clearly in the double shaded region. The only one that wasn't and is a non-solution has to be D. 22 is one of our favorite types of problems to put on there. We don't put them on there because we love them. We put them on there because the state of Georgia loves these type of weird problems where you have to find a mistake in something. Okay? So find this mistake. Well, if we've got these two equations, we're multiplying them by numbers out front and they're already lined up. I'm thinking this person is probably doing the elimination method. Okay? Well, if they're doing the elimination method, that means they distributed. When I distribute this, I should get a negative 8x, checks out, a negative 12y, checks out, and then positive 20, checks out. When I do my second distribution, I should get a positive 9x, a negative 12y, and a negative 9. So all my first step, my multiplications, they all checked out. All right? They were all done correctly by whoever did this problem. Good for them. Now, I have to find out not only what they did, but did they do it correctly? Well, like I said, it seemed to me like they were doing some elimination. So let's think about what happens when we run this elimination process. If I was doing this myself, and I actually will, I'll go over here to the side and I'll run this elimination myself. When I add these together, negative 8x plus 9x is going to be just a 1x, or just an x. Negative 12y plus negative 12y is where they messed up. Take a look. When I do negative 12 plus negative 12, they don't cancel out. It's actually a negative 24y. Now when I add my final column, it's 11. So look, X they got correct, 11 they got correct. What happened was they think that y is canceled out, but they didn't. Okay, it would be a negative 24y. You would write that in words to describe that they made a mistake in their elimination, and they should also that y's should not have eliminated each other. A lot of y'all look and say, well, that's a tricky problem. Why would you make such a tricky problem? Well, I'm going to show you all the steps to this elimination process. If I'm going to show you all these steps and make you find a mistake, it's got to be a tricky mistake, okay? It's got to be something a lot of people would oversee or would be an oversight. They would make that mistake. And this is a great example of that. A lot of people look and go, oh, yeah, those y's cancel out perfectly. Look at them, they're the same number. Well, if you were taking your time and doing this problem yourself, you would notice that it didn't work out, okay? In the end, really, they shouldn't have multiplied by a negative 4. They could have just multiplied by a positive 4. So you could also state that, say they multiplied by the wrong number to start, but really what we're looking for is where they made their mistake, which is right here in combining these negative 12y's.